Hi guys, and welcome to a new video. I know this is not the type of video I usually post on this channel, but I really wanted to make this video because every now and then I see some people struggling with Unreal Engine or even just C++, and they fail to understand what a pointer is maybe and what it's used for. So this video is all about what a pointer is and one of the useful cases in game development, why a pointer is very efficient. I know when I started learning, it was very tricky to get my head around what a pointer is and what a pointer does and what it's used for. So I'm going to try to explain with an example at the end what a pointer is very useful for and why it saves a lot of performance. Okay, so let's start. Let's start very simple. Let's just remove this. And by the way, I'm sorry, I'm using a random online IDE. I don't have Visual Studio on this machine, but in the next video, hopefully I should have Visual Studio. Okay, so let's make an integer variable. We call it n, and let's just say it is 10. Now what happened here, and if you know a little bit about memory and memory allocation, that's even better. But what's happening currently is somewhere in my memory, I have reserved 4 bytes because an integer is 4 bytes. And somewhere in my memory, I have reserved 4 bytes of memory to store any number. And I can prove it to you that it's 4 bytes by just printing it out. So if I now hit run, and by the way, this is how you print out or get the size of a variable type, so integer, double. I will show you, don't worry, but let's just run it. And as you can see, it's 4 bytes. If we were to try it with a character, so it should be 1 byte. And let's try with a double, which should be twice as big as a integer. And it's 8 bytes. So you see, different variable types have different sizes, so they occupy different amount of memory in your RAM, okay? So they all have different sizes and occupy some amount of bytes in your memory, okay? Keep that in mind. Okay, so let's make a pointer variable now. So to make a pointer variable, all we have to do is first specify the type of pointer. So I want to have an int pointer, and we'll call it pn for pointer to n, and I will show you why later. And I'll not assign it to anything at the moment, and this is completely valid. But the better thing to do, if you don't want to point to anything at the moment, just say null pointer. And basically that means, hey, the pointer is currently not holding any valid value. So do not dereference it, do not work with it. Before you work with it, check it and everything. But that's for later. Anyway, now I've created an int pointer, and I will explain the difference. But first, let's visualize how big a int pointer is. Okay, so it's 8 bytes, so it requires more memory than a normal int. Let's check out character pointer. Okay, it's also 8 bytes. That's strange. Let's check out a double pointer. Okay, it's also 8 bytes. Okay, so you see that every pointer is the same size. It's always 8 bytes. For now, just keep in mind that a pointer variable has 8 bytes. Okay, so let me explain what a pointer actually is and what's the difference between normal integer variable and an integer pointer. Okay, so here I made a little sketch. It's not that great, but on the right side, this is our memory, right? This is our memory. And over here, this is the address. Okay, so this is the address 1, 2, 3, 4, 5, 6, 7, 8. Of course, in the actual memory, it's not labeled like that. Memory locations are usually represented in hexadecimal, so they will usually start with an 0x and then with some hexadecimal value like 1, 2, 3, A, B, etc., right? But for simplicity, let's work with that. Okay, so this is our memory. And let's see what happens when I create a integer variable. And let's assign it to 5, right? Okay, so what happens is in our memory, I will, take out 4 bytes because we need it to store in an integer. So this is A, and we're storing the number 5 here, right? And we're also occupying these bytes. So each cell, one cell equals to 1 byte, okay? So I'm storing 4 bytes, or I'm occupying 4 bytes. If I create an integer pointer now, let's not assign it to anything at the moment. Integer pointer now, we saw that an integer pointer is 8 bytes, but I kind of misplanned here. So let's just assume an integer pointer is also 4 bytes. So what happens is I will also reserve 4 bytes. And this is my, 1 second. This is my A pointer. Okay, so the difference now, now you have to pay attention. The difference now is that a normal integer stores an integer value like 500, 250, million, whatever. A pointer variable always holds a memory address. It will not hold a character or a text or anything else. It will always hold a memory address in RAM. So you will see later that when we assign a pointer or give it a valid memory address, it will be represented in, in hexadecimal. But for now, we're gonna use the simple version on the right. So when I do something like this now, AP equals to end A. Let me show you what happens, okay? Let me show you first in code. Okay, I'm back here, and here I just use the AND operator and then the variable name. And what this does when you use the AND operator before a variable name, what happens is you will return the memory address of that variable. So you will get the address where this variable n is stored. Make sense? I hope it makes sense. So the end plus the variable name will return the address where the variable is stored in your memory. And we can even visualize it if I print it out. So now I will get a memory address. And this is where the variable n is stored in memory. Okay, if we visualize it here, if I do this, it will see, hey, my A is starting at memory 1, location 1. So it'll store 1. It's pointing to A, right? Therefore, it's pointing to A. This is why it's called pointer, because it points to the variable A. And we can do some cool things with it, and I will show you what we can do. So now I can indirectly access the content of n by using the dereference operator, which is this multiply symbol. And I can say now, hey, Pn equals 100. So I can indirectly change the value because I'm directly accessing where this memory, this variable n is stored. I go to that place and I then just assign a new value to. If I now print n, it should be 100 because I directly went to that memory address and then changed the content. Okay, so it's now 100, and I can even do some other stuff. So I can directly do this. So Pn, I dereference it, and now this stands for 10. Okay, this stands for 10, and I can say times 2, and we have to put this in bracket so it gets preference. So if I do this now, this is represented, or this under the hood is 10, because we are dereferencing pn. Okay, so you've seen that we can indirectly access the pointer variable, the variable n, and change the contents of it. But you might be wondering, hey, what's the point? I don't see any point. I don't see any use case. I can just directly do this, and it would be much faster and less cumbersome. And I agree. But let me now introduce you to an example what why it is useful. Okay, so I've made a little class here. So first I made a location struct, and this location is storing an XYZ double, to have a representation where a player or an entity is in the game. Then I've made a little player class, and this player has a name, an inventory vector, a health value, an attack power, and a location, because we also want to keep track where the player is. Then a little constructor and a little function called attack, which just prints out the amount of attack power the player is attacking with. Okay, so nothing very sophisticated. It's just a simple class. But now if I print out the size of player, so the size of player class is going to be 64 bytes. Remember how a pointer was only 8 bytes and how an integer is 4 bytes? And since we have a group of data right here, a group of different variable types, it compounds and now the player class has a size of 64 bytes, sorry. Okay, so now let's make another function so I can demonstrate the actual point I'm trying to make. Let's make a function that basically gets a player as a parameter and just calls his attack function. So for that, let's just write it. Okay, so as you can see, it's a very simple function. All it takes in is a player class, and then we are going to call this player's attack function. So let's make a player. Okay, so I've made a player, and I've made a player object and called him Mario. He has 100 health points and 30 attack power. So let's now call the function. And I'll get rid of this statement over here. I'll zoom in a little bit. And now if I hit run, Mario's attacking with 30 attack power. Okay, it works. So the point now is, what is actually happening is when we are not using a pointer or a reference and do something like this, where we just say player P, what is happening is that when I input my player in the parameter, this variable copies all the contents of Mario. So it will copy the name, it'll copy the amount of health it had and the attack power, and it works with a copy. So what I'm trying to say is that when you do this function will not work with your player directly. It will copy all of the contents that you have in your player and then work with a copy. And you might already wonder that, or you might already think that's incredibly inefficient, and it is. Because imagine you are calling a function in game every frame, okay? And every frame you are copying the contents of, I don't know, your player, your world, an object, and you're copying the contents and then you're working with a copy. But it would be more efficient if you could find a way to directly work with your player so you don't have to copy over and over again and then work with a copy, but instead just call the myPlayer function directly, okay, without making a copy. And I can prove it to you that we are working with a copy, because if I, under here, change P's health, Because if I now change under here, piece health to 20, you would expect, if you think it works directly with your object, that my player also gets updated, okay? But if I print out player's health now, it will still be 100, as you can see, because here we are just working with a copy. And as you can see, this is, I think, 64 bytes, right? In an Unreal Engine and other engines, classes can be way, way, way bigger. This is a very simple class. It doesn't even have a texture or anything. It's a very simple class with very simple functionality. And now imagine the amounts of classes Unreal uses, or Unity, and the amount of inheritance and all other data that is very... It would be very inefficient, and you would cripple your performance quite a bit if you copied every single variable one by one and then worked with the copy. So instead, what we do is we're gonna say player pointer, and we can also use reference, but for now let's use player pointer. And here, therefore, we have to dereference, okay? And now I can directly access everything from my player without making a copy. So you will see when I change mHealth, it will also change mHealth of my player. Okay, let's see. Okay, what's going on? Okay, oh, here, remember, we have to get the, since this is a pointer now, it stores a variable address, it stores an address in memory, we also have to return the memory here. The memory address here. So now, as you can see, I changed mHealth in the function, and now it's not working with a copy anymore, and it also changed the health of my player over here. And that is way faster, okay? And now you might be thinking, well, this seems kind of dangerous. What if I just want to read some values and not necessarily accidentally change anything? Well, for that, you just say const pointer, so const, and you also have to say attack const, because we are not changing anything in the function. We are not changing any variable. We're just printing a statement out. And now it works, but I cannot, I cannot change the mHealth value anymore. So if I try to run it, it says, mPlayer is just read only. So if I remove it, or if I comment it out, it should work. And this is one way how you can, efficiently pass data to functions and be sure that inside the function you're not changing anything. So you're not accidentally updating health or attack power, you're just calling some functions. And this is one use case of pointers, and why pointers are really incredible, because they allow you to basically speed up your code. Because again, imagine, you would call player attack every frame, and it would be way larger than 64 bytes. It would stack up quite a bit, right? But now we are directly working with the player object, and now it's very efficient, okay? Because it's directly working with that. It only has to look up the memory address. And remember when we said, a player pointer was only 8 bytes? And now we are only, passing 8 bytes, or we are only creating a variable with 8 bytes, right? Because a player, this variable is also somewhere stored in your memory, but it only has the size of 8 bytes, not 64 bytes, right? But it wouldn't really make sense to use an integer pointer or a character pointer, because if you think about it, an integer pointer is only 4 bytes, and a character pointer, integer variable, is only 4 bytes, and a character variable is only 1 byte. And if I use a pointer for these, I would be using more memory actually, because a pointer is 8 bytes and an integer is 4 bytes. So in these cases, it really makes sense to not use a pointer, and you can just use an int directly, okay? Because it's not an int here, but I'm just demonstrating. But the point is, it doesn't make sense to use a pointer here, because when we use a pointer here, we're using more memory. So a copy makes total sense here, and it doesn't really matter. So that's all about pointers. I know pointers have a lot more applications, but this is just one application I find is really useful to demonstrate and visualize why we are using pointers. And in this example, yes, it looks like, 64 bytes, it's not that huge. Let's just copy it. But Unreal Engine, the classes Unreal Engine are way, way bigger and use way more memory. So it makes sense for that type of stuff to use pointers. I hope you liked the video. I hope it was helpful, and I will see you next time.